All right, well, thanks everybody for coming. It's amazing. So I was at the University of Rochester before here, and what I love, well, of many things I love about CMU is you can give a talk in the very same room, not many weeks apart, and have what looks like an entirely different audience. So that's great. So I'm going to talk about crowd agents. This is work that's kind of based on our experience having built and deployed what we call crowd-powered systems. And so these are systems that not only rely on automation, computation to do interesting things in real time, interactively to support users, but also kind of leverage people out on the web, so the crowd, in real time to make these systems smarter, so to do things that we wish we probably could do with computation, but we can't quite figure out how to do yet. And so what I thought I would do is go through this quick outline, which is basically talk about some of the systems that we have developed in this space. As you can see, they kind of run the gamut of a lot of hard problems in computation. So we have a system that answers arbitrary visual questions. And so this is actually targeted at blind users. So it allows a blind user to ask an arbitrary visual question about anything in the world and get an answer back within a few seconds. We have a system, a crowd-powered conversational assistant. So something that you can chat back and forth with, have a real conversation with about anything you like. So general domain conversational assistants. We have a system that you can, if you want, turn over control of your desktop computer interface to the crowd to do something that maybe you don't want to do, that's a little bit mundane, and you'd rather have somebody else do it. So talk a little bit about that. We have a system for activity recognition. So this is, in our situation anyway, it's to support people with cognitive disabilities, for whom if you can understand what they're doing, say in their home or elsewhere, you can better support them. And then finally I talk about a system called Scribe, which is a crowd-powered real-time speech-to-text system. So something that can work on even poor quality audio, new domains, new speakers that it's not trained for. And so these are all crowd-powered systems. And what's interesting about it is that because they're crowd-powered and because we can recruit these workers, the workers to power them in real time from off the web, we can actually deploy them. And what we're starting to kind of understand is that by deploying these really intelligent, smart systems that many of us are working to build automatically, we're actually, I think, learning a lot about how and what we might want to work on in doing this automatically. So clearly, there are challenges with the crowd. For instance, they don't scale, they can be expensive. That doesn't always hurt all of these applications because of how they're done right now. So for instance, Scribe, we're working with deaf and hard of hearing students who are currently paying somewhere between $120 to $300 an hour for reliable speech-to-text in their classrooms. And so if you can do this for a little bit cheaper with crowd workers, then that could be a big benefit. But in general, we want to reduce the cost. We want to allow them to scale by turning this over to computation. And so what I've been seeing is that it seems like these crowd-powered systems are offering kind of a scaffolding that I think we can use to then explore automated approaches to many of these problems. So I'll talk briefly about that at the end. So onto these systems. So the first I want to talk about was VizWiz. And so VizWiz is this one I mentioned where it allows a blind person to take a picture, speak a question they'd like to know about the picture, and then get answers back to that question pretty quickly. So within about 30 seconds, they get an answer. I thought I'd show you a quick video. This is somebody, we released this, and this blogger, blind blogger, just recorded a video of him using it. He kind of gives a little short tutorial about how to use it. So I thought I'd just play it. He's probably better at describing it than me.
Options as to what sources I'm going to pull the results from. I'm going to select web workers and IQ engines, and so I'm just going to go ahead and send. So it's going to send my question. So web workers will actually pull information from human sources. IQ engines, I imagine, pulls it from image databases, somewhat like Google Images. You also have the option to pull results from social networks. I think Twitter is the only option here now, but on the website for the application, they talk about Facebook being an option. So let's see. It already has some answers available. The IQ engines has it labeled as a thermostat, so we knew that. That doesn't do me too much good. I'm going to get a temperature reading. So if we just hold on here for a couple more seconds. Earlier there was hopefully within 45 seconds, so just hang tight here. It did identify the temperature. Okay, a web worker said that 75 is on the left and 71 is on the right. They're not sure what the current temperature is. I can tell you that 71 is what I had it set at, and 75 is the current temperature. Is that correct?
Yes.
All right. So we have 2 pairs of eyes that says that's correct. So that was pretty quick.
All right, so I'm going to stop the video there. I think there's a few points I want to make already at this. So first of all, I think maybe if you're not familiar with this, it's pretty fascinating. A blind person can take a photo. They can use their iPhone, which is also really interesting how that interface works. You also saw a little bit about how a blind person goes about taking a picture. And this is a pretty common scenario, it turns out, talking to people. They'll hold the camera pretty close to the thing they want to take a picture of and then kind of move it back so they get a sense of where it is. I also thought it was pretty interesting. So we do have an automated computer vision answerer in this system, and it's just a general one. And so it was able to actually work in this situation. It said that that was a thermostat, and that's actually pretty good, that it was able to recognize it as a thermostat. People were able to listen to and answer the question, and they're also able to express some uncertainty, right? So there's just some numbers on the thermostat, and they weren't sure, and they were able to convey some of that uncertainty. Now, if you work in computer vision, you might be looking at this and say, well, we can recognize digits on a thermostat. And I think that's exactly the point. I think the point is not that you couldn't do this. It's that if you want to support just general use cases, there's thousands and thousands of different kinds of questions, some of which I'll show you in a second. And it's really building up this framework that you can deploy that can work generally, and then you can start injecting those automated approaches into something that is deployable, that is usable, and that really meets at least this particular user's needs. And so that's kind of what I mean by scaffolding. Scaffolding with the deployable crowd-powered system, and then adding in the automated approaches where you can. You'll need to watch it again. So we did deploy this, and one of the interesting things about this is we were able to actually get a lot of users. So we had, well, now I think it's a little over 6,000 and probably over 70,000 questions. And I just wanted to give you a sense, just to show you the kind of difficulty, if you're going to try to answer these questions automatically, of the just diversity of types of questions. So this is a page, it just has about 1,000 questions on it. And let's see, I have some of these preloaded here that I want to show you. So this is a picture. You can tell this is a picture actually taken by a blind person. It's the back of the box of medicine. They want to know what medicine this is. It's upside down. It's kind of poorly framed. There's some glare. And despite that, the crowd workers can kind of look at the main ingredients here, pick it apart from all that rest of the text, and tell them what's in this box of medicine. This one's, is there a rash on my baby's head? So would we create specialized computer vision that would tell me if there's a rash on my baby's head or not? Maybe. This one was kind of fascinating. It was kind of early on when we were still monitoring closely what was going on with VizWiz. The person says, what does this part of the sky look like? And you only see one picture here, but the same user actually asked this question every 5 minutes over an hour. And we were really worried because, as I said, we're kind of worried about cost and scaling and whatnot. And so we thought, wow, if users are just going to ask the same question over and over again about what the sky looks like, we're never going to be able to support the system. But anyway, after this hour, this particular person stopped asking that question. And we happened to notice on Twitter, someone at the same time said, I just used VizWiz to watch the sunset. And so it did turn out that over that hour, the sun went down, and so our answers went roughly from it's kind of blue to it's kind of dark. And so VizWiz let this user watch the sunset. let's see. So here you're kind of getting at the limitations of this approach. You got this complicated machine. It looks like a coffee maker that they have at like Microsoft, and they say, basically, tell me about all these buttons. It's kind of hard to tell them what all these buttons do in a way that makes sense in just a text field. You also notice there's a credit card there. Surprisingly, we do get actually a lot of credit cards sent to us asking for numbers. So if you get a credit card in the mail, again, you could solve this. I mean, people have solved this for other purposes, right? So I forget the name of the startup that's kind of a competitor to Square, where they let you just take a picture of the credit card to charge the person. So we know how to do this. It's just kind of fitting it into this general framework where people can easily access it. This person wants to know if basically if their outfit looks good together. This gets at subjective questions, which are kind of difficult and dependent on the person and the context. We did a whole other study looking at. I did not lead this. Don't worry. I was not. I don't think my fashion should be forced on anyone. But at the same time, there's a lot of people that want to know, do their clothes look good together when they get ready in the morning? And it's something that automated approaches still have some trouble answering. Let's see what else we got. So another limitation of this kind of approach is it requires the user to take a good picture. And so this is a pretty common scenario where here's a box of food. They're asking how they cook it. You can't tell in the first picture or the second or the third. They're getting closer, and the workers are actually helping them get closer by telling them, maybe flip over the box, or this is the right section, but it's too blurry. And then finally, even though this is pretty blurry and dark and especially unreadable on this screen, the worker was able to answer how they cook it from these photos. Let's see. Also get a lot of questions like this. Here's a computer screen. This works really well if you can see it. When your computer crashes or something, it shows you information about what's going on. I think this is just a disk scan or something. But if you are blind, your screen reader also doesn't start if the computer doesn't start, and so you can't read this without assistance. You get actually surprising things like this. So what does this test say? If you can't see that, it's a pregnancy test. Would you create a specialized computer vision program for recognizing the results of a pregnancy test? Maybe. We have delivered the news twice, actually, and they've both been happy, well, we hope happy news that a baby is coming. So. And then that's back to the beginning. So you kind of get the sense that it's quite diverse, and this is a big departure from the automatic technology that is at least out and available in the market for blind people, which mostly deals with things like OCR for recognizing text, color recognition, that sort of thing. And yet what people want to know in their real life is much, much more diverse. And the kinds of pictures that they take that would allow a tool like this to answer are not the highest quality. And so which makes the computer vision even harder to work. So one thing we kind of cast all of this in is that this connectivity that we have to these workers allows us not just to access things like Mechanical Turk, but a whole bunch of different sources of crowd, so like volunteers, friends and family. And so we actually did a study to kind of get a better sense of how the users view these different types of sources of crowds. And so in particular, we had variations of the app that charged different prices for web workers, which is roughly Mechanical Turk, although other kind of paid workers, IQ engines, which is computer vision, and then we made social networks free because we thought, well, if they're going to cash in some of their social capital, we shouldn't charge them on top of that. There's a lot of interesting results from this, but the main result is that people, despite what some initial impressions might lead you to believe, did not want to ask their social networks questions. And the reasons for this were things like latency and social costs, and they also kind of liked the fact that they were anonymous. And one of the take-home points of this was that even though they knew that web workers were people, they still kind of saw it much more closer to computer vision than to their social network, because they don't know the people, and because they don't know the people, it's almost as though it doesn't matter that it's people, and it's almost like computer vision. Whereas their social networks, it was their friends, their family, their the people that could most likely, they'd most likely to be potentially embarrassed from seeing their question. People would tell us hypothetical examples of things like, well, I'm not going to ask like my social network if my outfit looks okay before I go on a date where I'm friends with my person I'm going on the date with. So all these kind of real world scenarios. I will talk just briefly about how we get the crowd to answer questions quickly. So essentially, we just post jobs to Mechanical Turk. We keep workers answering old questions, and that way, when a new question comes in, they're there and ready to answer those questions. And we don't have to keep workers around all the time. We actually use a signal. So like basically, when the user opens the application, so when they open VizWiz, we start recruiting workers. And it turns out that gives us a pretty good lead time to be able to recruit workers in time for them to be there when they're needed. One kind of interesting thing that I thought was that the response time, as opposed to kind of an automatic system, the response time for the crowd system is very much dependent on the input that you give them. So for instance, if, as you might imagine, given some of the problems we saw with the pictures taken, some pictures questions cannot be answered from the pictures that are sent in. For those questions, it actually takes longer to get a response from the crowd. Even if the end response is, I can't answer this question, crowd workers are less likely to do it, and they take longer trying to figure out if that's really what they should say. And so you see a difference here between the time taken for answerable and unanswerable questions. We also ran speech recognition on the question. It turns out that can speed up response time if that way they don't have to listen to the whole audio. It also means that workers who don't have headphones can answer the question. And so that actually made a difference. In the end, if it's both answerable and speech recognition worked, we got the fastest response time. So I might figure out what the answer is to that to give you a sense of what color is this shirt. We got their hand over the lens. And so like that kind of question takes a long time. A big fraction of this time is recruiting the worker. And so it turned out that for about $4 an hour, we can actually keep workers around all the time and get the response time down to under 30 seconds from start to finish. So basically, it's just the time that it takes them to look at the picture, perhaps listen to the question and answer it. And so that's pretty good. It's not quite as fast as people want, but it's getting close, really close to interactive speeds. Yeah.
So you measured speed here. Did you measure quality at all? Like if you have like a mean Turker that gives random answers?
Yeah, so we didn't see too many mean Turkers. I think there's some rough rules of thumb you can use. I think what I've seen that seems to match our experience the best is about 30% of Turkers are kind of the lazy or whatever reason don't necessarily give the best response. I'm always hesitant there because it turns out that like the better you design the user interface and the task and make it clear what they're supposed to do and and give them feedback about how they're going to be rewarded, you can kind of drive that number pretty far down. It's somewhere though around like 1 or 2% of Turkers that are actually giving malicious answers. It's actually a lot rarer, I think, than people commonly think. Yeah. So for the majority of the questions, except for that study I mentioned, we're actually paying everything, and it's not nearly as much as you think it would be. So it's over the course of the 2 or 3 years it's been deployed, it's $2,000, and which we paid from research funds to understand things like what people actually want to ask about, that sort of thing.
So the users pay for the actual questions asked?
They don't outside of the study. We've just made it free for them. Okay. I should have made that clear. So one thing that our approach to recruiting this crowd quickly has led to is a characterization of the crowd that we've used in kind of as a basis for designing some of our future systems that I'll talk about. And so essentially, what you can do with recruiting groups from services like Mechanical Turk is that you can get a group together, but sometimes those workers will go, right? So the workers come and go, and some of them might do the wrong thing, as we mentioned, and that might be your fault or their fault or some mix of the two. Yeah, bathroom people are crowd workers, and upside down bathroom people are, I guess, the ones who do the wrong thing. And so it means, though, if you're trying to have a longer-term interaction with the crowd, the fact that they might come and go, and some of them might give you bad answers, it makes it more difficult. You have to think about, well, how are you going to maintain a more continuous interaction with the user? So for something like this, which we saw in the VizWiz example, or something we've done more recently is actually given the blind user a live video stream, which they can share with the worker. So here's a kind of scenario. This is just fake data, but walking around Microsoft Research trying to find the coffee maker. How would you actually get the crowd to support this? It doesn't really fit with this kind of micro-task model that we've often thought about with crowdsourcing. I think unfortunately thought about, but still thought about crowdsourcing. And the reason is that if I just hook up the user with a single worker, that worker might be one that is bad or disappears. And so what we do instead is basically connect the user to multiple workers. The challenge, though, is if you're trying to have a conversation with multiple people, it can get kind of confusing. And so we introduce this mediation layer where instead of connecting the worker directly with each, or the user directly with each worker, we connect the user with the crowd kind of as a collective. And then the question becomes, how do we actually make sense of the multiple contributions from different workers? And we can do that maybe algorithmically, and maybe we can do that with the crowd. And maybe kind of highlighting or foreshadowing or something toward this scaffolding approach, maybe we can even start to learn from what we see these workers doing to start doing automatic mediation, or even start replacing some of these workers with computation. And so this is roughly what we're describing as a crowd agent. And so I'm going to describe a few different systems that kind of fit into this model. And for each one of them, things you might think about are, given that there's so many different workers contributing, that they're coming and going, some are good and bad, how do you actually maintain consistency? Right? So you don't want to have this interaction with the user be kind of, oh, I'm talking to this person now, and now it's a completely different perspective. And so how do you maintain consistency? How do you mediate all the different contributions of the workers? And then, to what extent could you imagine or are currently automated agents involved? So the first system, and I'm going to describe all these systems pretty quickly just for time, but the first system I'm going to describe is called Chorus. And so this is where we're trying to allow an end user to have a consistent conversation with the crowd, so a group of people who are coming, going, good and bad, as if they were a single individual. And so what this looks like from, I guess this is the worker perspective, is we give them what looks kind of like a standard IM chat area. We give them a area where they can promote things to a working memory. So you might imagine if people are kind of coming and going, it might be important for new workers to see what happened before, especially important things. So if you're asking them about a restaurant, you've already told them that you're allergic to shellfish or something, maybe the workers who come later shouldn't start recommending seafood restaurants, things like that. So a chat window and a working memory. Just to kind of show you again how this works, here is a conversation that we have had with the crowd. Starts out pretty normally. Hi, how are you? I'm good. How about you? Good. I'm on vacation in Los Angeles. Blah blah blah. Anyway, so it leads down to working through finding out where the person is and finding a good restaurant that they might want to try. Behind the scenes, all of these responses from the crowd, the red people, are actually chosen from a number of different suggestions given by a number of different workers. And so even for something as simple as, hi, how are you, especially because it's the first message, and so some workers are brand new, they're drawn from a number of different suggestions. So the first person says, I am fine, but wondering if we can do this more than once. So basically they're asking about the task. Does anyone know if we can? So now they're kind of talking to each other, which you might imagine leveraging, right? Like they could actually kind of talk to each other, kind of negotiate about what a good response is, but here they're just kind of going off. How is everyone doing? Are there any questions? So kind of close, but they didn't quite get the idea that they're trying to just talk to one person, pretend that they're one person. Are we the only ones in here? I don't know who else would be in there. This is great. Anyway, so someone comes along and says, I'm good, how about you? And this actually ends up getting voted through to the actual conversation. And the rest of the conversation is formed of different things like this. So suggestions, and then some are voted through. So the same crowd that's suggesting and is also voting. And so there's this incentive mechanism that's supposed to make sure that their incentives are properly balanced, so that they suggest and that they vote, and they're rewarded more if their suggestions are chosen and if things they vote for are chosen, that sort of thing. It works reasonably well. Another example I thought was funny, we put this out at WIST, the User Interface Software Technology Conference, at a demo, and people just tried to trick it. It was at MIT. Someone said, what's the best place to get a drink at MIT? Someone came up with something. Another person came along and tried to mess with us, said, I need an answer in pounds or kilograms. How much wood would a woodchuck chuck if a woodchuck could chuck wood? And the crowd comes back with the amount of wood that woodchucks would chuck on a given day varies greatly with the individual woodchuck, according to the Wall Street. Answers the question. Now, clearly they didn't know this or make this up, and so they found it. I'm sure they found it on the web. But nevertheless, that seems pretty smart. And so it's another way we're looking at this is kind of a different interface to collaborative search, right? So if you have a bunch of people that are all kind of doing searches in support of your interests in parallel, maybe this kind of an interface is a way to mediate that well. So I'll revisit Chorus near the end, but that just kind of gives you a sense of what we can do with on general topic questions with the crowd. Let's see, so Legion is the next system I want to talk about, and this is where we put the crowd collectively in control of your desktop via something like remote desktop. So the idea is that you have multiple crowd workers connect, you give them kind of a natural language description of what you want them to do, and then they all start issuing commands. And so we have to make sense of those commands in some way. So the first thing we came up with, so basically take all these commands that are coming in here, condense them down to a single stream, and hopefully allow them to do something useful for you. So the first thing we came up with was, well, maybe they could, one way that we often make sense of crowd work is to essentially take a vote, right? So get some consensus of the workers. Doing that actually requires you to break up, if you have a real-time stream of these inputs, would require you to break up time and into segments so that you could vote in those segments. And so the result is this, you can only issue an action at the end of each segment. What we ended up doing instead, and what ended up working pretty well, was using that vote, which is slow, not as to choose the best action to send on, but actually to elect the worker who would have direct control of the interface for as long as they kept agreeing with the crowd. And so some short results, but basically solo, because the crowd comes and goes, if you turn over the control to a single crowd worker, they actually are pretty quick, but in our studies, in this one particular study, I think we were driving a robot around. I'll show you an example of that, but we were driving a robot around with this. And they only completed 4 out of 10 trials. Mob is kind of where we just like mash all the input together and forward it on, which you might imagine is a bad idea most of the time. That was a little slower. And the robot, it was okay because it's kind of just averaged out, but still only 8 of 10 trials. And vote was a lot slower, 8 10 trials. If we just select somebody randomly, so we didn't use the voting mechanism to elect somebody, we just elected them randomly. They completed all the trials, but not as fast as if we elected the leader based on the vote. And so what's interesting is that this kind of simple mechanism works across a number of different tasks. So we've had them transcribe this table. So we drew a table, took a picture of it, had them transcribe it into this spreadsheet. And that worked pretty well. Got a similar results as to the robot. Robot looks kind of like this. So here's the one crowd worker's view of driving the robot around. We're trying to hit that tea kettle. It's a very simple navigation task. I'm sure that if you actually work on robotics, you would not think that this is the most compelling thing. But getting the crowd to do it is potentially interesting because you can tell them what to do in natural language. And eventually, our hope is to push this out to more complicated tasks like that computers, or that we can't do easily automatically already. Let's see. So activity recognition. So what we do here is we share a live stream of the video to the crowd workers. There are various things in place to protect the privacy of the user. One is that they get a 2-second, I don't want to send this out, when it detects something that it doesn't know how to recognize. And then the other is, I guess it's not shown here, but we have, we blob to people's faces. We put just a color over their face so you can't see who they are. Anyway, so a bunch of workers are seeing this. They're all typing what they think is happening. And then they're also kind of seeing what other users are saying is happening as a way to kind of get them to agree on what's happening. One thing that we noticed, so we actually had this hooked up. Should put this on first. So we had this hooked up with an automatic HMM-based activity recognizer. And one thing that was interesting was that if we put the HMM's suggestions here in the automated suggestion area there, even if it was wrong, it kind of helped set the granularity that the crowd would suggest. So if it said making breakfast, they were less likely to say, dipping a spoon, like something really low, or high level, like, living in their house. And so again, it's kind of neat because one way we were motivating this was that you wouldn't want necessarily the crowd to do this all the time. There's privacy implications. It's going to cost a lot. It's probably going to not scale very well. But it does help the automated system scale in a very particular way that is a problem for these systems, and usually, which is that they're difficult to deploy because they need to be trained for each activity, each environment, that sort of thing. And so if you could come up with a good way to trade those things off, where the automated system works independently most of the time, but when it's unconfident, or maybe when it's just starting out, the crowd kind of takes over labeling the activity, and those labels have been fed back into the HMM. All right, so the final system that I'm going to talk about is called Legion Scribe. And so this is basically real-time captioning by what we call non-experts. So this could be crowd workers from Mechanical Turk, or it could be people just sitting in a classroom, so maybe work-study students sitting in a classroom. So the problem is that for deaf and hard of hearing students, as I kind of already mentioned, one accommodation that can be useful is to have a real-time transcript of what is happening in the classroom. So if there's a lecture going on, there might be another screen where you'll see the captions there so that they can participate in the mainstream lecture. Right now, there's two main ways you might think of doing this. Maybe the first that would come to your minds would actually be the ASR, which is cheap. You can make it available on demand, and you can train it in various ways to match the environment, the speaker, maybe even the audio. It turns out that in practice, ASR is never used for this because it's just not reliable enough, and it's just not fast enough, at least the ones that are commonly commercially available. And so what we do instead is there's professionals called stenographers who are able, through training, to type on a special corded keyboard that roughly maps syllables then to words. They can type at very high speaking rates, so 250 words per minute. We met a guy at the recent Assets conference. I don't think he has the Guinness World Record, but he was like competing for it. He's a gamer. He's only been doing stenography for about 3 or 4 years, but he was a gamer, and he can type pretty accurately at 350 words per minute or something like that with the right keyboard and training, and it's very much macro based. So each stenographer has their own like set of macros in their head where they have assigned like certain keyboard shortcuts to sometimes very long phrases, and so the more you can remember and the faster you can apply them, the faster you can type, and you can get up apparently to 350 words per minute. So imagine that. Anyway, but the problem with them is that they are very expensive, so $120 to $300 an hour. They can be very difficult to schedule, so usually a day or more in advance, and usually for a block of an hour or more. So that means that it's really hard for a deaf student who wants this accommodation to just show up at the last minute. Like people do when the quarter starts or semester starts, shop around for classes. That's very hard to do if you're deaf or hard of hearing because you wouldn't have the accommodation you need in all of those classes you might want to try out. It's also very hard to, say, have a quick 5-minute meeting with your coworkers. It's much easier to have an hour-long meeting scheduled days in advance, but it's hard to have those 5-minute meetings that might be really important. Despite their skill, they lack domain expertise. And I'll show you at least one example that we thought was could be particularly confusing later. So the stenographers are professionals, they're experts, but they're experts at stenography, not at, say, computer science or whatever the domain is that they're captioning for. And so basically stenographers are pretty accurate, and that's why they're the only accommodation that's used. And ASR, we can't use it yet. I asked, can I help, right? I've done this before. I've been a note taker when I was in grad school, a note taker for students with disabilities. But it turns out, despite my little thing here about, can't use it, no, I cannot help. And it turns out, and I'll quantify this, I am worse than ASR. So we'll see that in a second. So what we did instead was we built the system Scribe, and it modifies the kind of common real-time remote stenography setup. So instead of having one person kind of get the audio from the user and then type what they can, which doesn't work because if that captionist is me, I can't type enough. I can't type more than a quarter or something of what's being said. Instead, we kind of use this model that we've looked at before, where we have multiple people all collectively typing bits of what they hear, and then we have an algorithm merge those pieces together and return the final output back to the user. So one important challenge is actually getting the different people to type different parts of what they hear, right? So if you just say, hey, type some of what you hear, there's kind of natural saliency differences that mean that a lot of people will type the same things. They'll also avoid the hard words. And so we built this interface that actually does this reasonably well, that encourages them to type different parts of what they hear systematically. So that looks kind of like this.
And it's still with us. And what came later in the 19th century forms of mail electronically through the telex network. And then telex was generally of course is still with us. The telephone being as you.
So there's a few quick things I want to point out about this. So this interface is designed to not only just kind of direct people to different parts of what they hear, it also is as you might have noticed, there's a visual indicator, but probably more important, actually, it changes the audio level, which means you don't have to be looking at the interface to see that. It kind of also cues people up with a little countdown. It's designed to kind of encourage real-time input, so as you type, it doesn't actually let you go back and fix things, which people really want to do. And that's because after a few seconds, it's actually too late. So if the captions come to the user much more than 5 seconds after the speech happened, then it's very difficult for them to connect it back to what else is going on in lecture. So if I point at this and then you don't get the audio that went with that for 10 seconds, it's pretty difficult to then figure out what was happening. And a lot of our systems now, these kind of continuous systems, use the same like point scheme. So we want to give users real-time feedback of what they're doing, our workers real-time feedback of how well they're doing. And so in this case, what we're doing is we're basically doing spell check and a little bit of agreement. So what we end up doing in the end is not giving people completely different segments of audio, but overlapping them a bit. And so we do have a sense of how well they're agreeing with the other workers. And we can use that to both visually change the how the words look as they kind of rise up, but also turn them into points that match how well we think they've done. While it might seem silly, points seems to work pretty well. This is on Mechanical Turk, so there is actually, these points get mapped down to a much smaller dollar amount. Anyway, so that's just a few things about that.
Still with us.
So one thing we wanted to know is, could we even, so coverage, you can think of kind of like recall. So how many of the words spoken were we able to recover? So a stenographer, it turns out, is not as high as we might have thought. It's about 90%. ASR actually is pretty good. It's about 33, 34%, at least in, this is over a number of clips, number of trials. This is Dragon Natural Speaking if you're interested. The average worker, which I'm about average, actually does worse than that on recall. And so that's why I said I am actually worse than ASR. The collective, which we've done a little bit better now, but the collective actually approaches and then exceeds the stenographer in this about 6 or 7 workers in. So it's a lot of workers, but at $120 to $300 an hour, we can actually perhaps afford a lot of Mechanical Turk workers. Just very briefly about how we get all of these things in, and then we have to stitch them back together. So we're using multiple sequence alignment, which is, we actually knew of it because of, it's how they stitch back together the little bits of sequence DNA they use in shotgun sequencing. So basically you have all these gene sequences. You can't sequence the entire genome, as I understand. I apologize to any computational biologists out there. But what you can do is sequence reliably little short snippets. And so they blow it all apart, sequence those little short snippets, and then they have to stitch them back in order. And they use overlap to stitch them back in order. It turns out that we have a little bit more information, which is the time that the words come in, and also the sequence in which a particular worker has typed them. So we, at first, created this dependency graph model that kind of was doing something similar, and then later went back and actually made it work with MSA. And it turns out with some heuristics, you can do this in real time as well. So that was the original problem, is that we couldn't do it in real time. Let's see. This is one set of results we got. I think we're doing a little bit better, but essentially, if this is more like a precision recall graph, and so higher is better. CART is up there. CART is real-time stenography, particular kind. It's way up here. We're kind of on different lectures, getting close. ASR doesn't do so well once we look at it like this, because the recall is better than an individual worker, but the precision actually ends up being pretty low, depending on a lot of different factors like the environment. But if you just put a microphone here, this is roughly what you'd get. Let's see. Failures. This is a failure of the stenographer. I mentioned I'd show you at least one, so I stuck it in here. This is a computer science lecture where the real word is in factorial, which you might imagine comes up a lot, but it got mapped to in pectoral, like pectoral. And the syllables are kind of similar, and the captionist is not a domain expert, and so this kind of error can happen. And even if it doesn't happen too often, if you try to think about what it might be like to be a student who's not only learning something that's new to them, right? And it might be complicated. A lot of times that's what it is, right? A student is trying to pay attention, and if even 1 out of every 20 words or something has a substitution like this that's really difficult to make sense of, then that can be really bad. I'm going to talk just briefly. So one thing that we've started doing is trying to make the work even easier. So playing off the fact that there's multiple people all doing this allows us to do things like make each captionist's job easier without hurting the overall performance. And so we call this one approach TimeWarp. So the idea is that right now, what I've presented so far, we're kind of splitting the audio into segments and having each worker type a segment. But even if they're only typing a segment, this is really hard. The whole point of why we have multiple people doing this is because the speech is actually coming at them too fast for them to type with it as it goes. And so even if we only give them a piece, what they're really doing is remembering and then typing later, right? And so we give them time to type later on these off segments, but they still have to do that, and that can be pretty challenging. So what we can do instead is actually slow down the audio. And so each worker is presented with this slower form. And then we speed up the rest to give them context. So that part that had a lower volume before, we actually speed up so they can still get the context. And they still remain overall in time with the global sequence. And we can do that across all the different workers. And I'll just show you what that sounds like, because I think it's kind of neat.
Which arose during my lifetime. Television, as you know, is one way, and we continue to get paid for to advertising, although increasingly
So it's a little silly, and if you were looking closely and you somehow remember the last one, the difference really, and this is what I found, and it seems to be what we find with workers in general, is that you're able to actually keep up, and so like, the typing actually happens in step with the speech. And this person, wasn't speaking probably as quickly as I am right now, but still speaking pretty, at a normal rate. All right, we don't need to learn about the television networking. And so what was interesting is that while you might expect that if we slow it down, we make it easier for people, that they would get more of the words, and maybe even get those words more accurately, it turns out that latency even went down. And so our hypothesis about this, which we don't have clear proof on, but which seems like the case, is that they're not doing what I said. They're not remembering and then typing later. They're actually able to type it as they go, which means even though the optimal performance is actually less because they're not hearing the end of that audio, their little snippet, until later, overall they're still faster because they don't have to kind of remember it and go back and correct and everything. All right, so this is kind of the end of the Scribe, but I want to just highlight a few things. So one is that we can actually have subject experts instead of captioning experts as captionists. So that's a kind of interesting thing. So you have a work-study student in computer science, or a set of them, caption a course as opposed to somebody who doesn't know about computer science. We're actually able to do this for pretty low cost. I mean, there's a lot of variables here, and so coming up with a particular cost is hard. But we paid about $30 an hour for the results you saw on Mechanical Turk, and you could make them free, right? Like I could actually help now where I couldn't before. You can also recruit these people on demand. We've seen from VizWiz and some of these other things that you can recruit people from services like Mechanical Turk, basically for only as long as you need, which could be a huge advantage, because then somebody could have captioning for the 5 minutes that they want it, as opposed to arranging for an hour. And we can also make the work easier by slowing down. And so by working as a group, we actually have more levers, some more things we can do to try to make the task easier for people. All right, so I have maybe 2 minutes. And so in the 2 minutes that I maybe have, I want to just talk about this idea of scaffolding, which is kind of one way that we look going forward to try to introduce more automation into these systems. So you already have seen some examples of where automation has been introduced in here. And I hope, because of this audience in particular, you're already thinking, well, my system could do part of this, or like all of this, and that would be great. So what I think is interesting about these systems from that context is that we can actually deploy them. So we can understand, before we know how to build them, we can understand how people might want to use them in their everyday lives. And so I just have a couple of examples here. So one way that I think we've started to scaffold VizWiz is that by getting all of these examples of questions answered by the crowd, we started being able to push those answers into a set of automated approaches that then can maybe start to answer some of the questions, right? So we already have, we can already answer basic currency questions, what kind of bill is this, which is a common question. We can do that automatically, and so we can start introducing that into VizWiz. Color recognition, right? Something that a lot of questions are about. OCR, to some extent object recognition. All of these things can be introduced into the system so that we're not always having to rely on kind of costly, difficult to scale people. We've also been looking at things like how we can use automation to actually make the input better. And so we have a whole line of work on what we call blind photography, right? So basically supports to help people center, frame, make sure that the pictures aren't blurry, that sort of thing. So basically taking better pictures that we can then feed in to either the crowd-powered or the automated approaches and actually improve the performance of both. Another thing we've been working on more recently with some people here, Alan and Kenneth, are taking Chorus and trying to figure out where all the places are. And it turns out there's a whole bunch of them potentially where we can start putting in automated approaches. And so this is roughly a different way of looking at the same Chorus system, where you have kind of the crowd workers here, the retainer model supplying the crowd workers, the interface for them to work in, the incentive mechanism, the way of kind of choosing responses, this memory space. And it seems like there are basically automated approaches to doing almost all of these things. And so here is a pretty complicated diagram of at least some of those things. So basically, figuring out if we have a whole bank of dialogue systems, where could we actually use the input of those dialogue systems, which may be very specific right now, but could be incorporated into a broader context. How do we use the data that's being collected by general knowledge bases like NEL to maybe either help the crowd workers answer questions better or more quickly, or even maybe how do we feed the conversations back into something like NEL to learn things that just don't appear that often on the web. How do we figure out maybe automatically what should be put into this memory space? How do we automatically suggest things from that memory space that may be relevant for the current conversation? And how do we do all this? I'm kind of stuck here in the middle, and I'm just kind of picking and choosing. But how do we do all of this in a data-driven way, right? So if we can release a general conversational assistant, maybe we can start to collect data that would allow us to do more of these with data in a way we couldn't have before necessarily because we didn't have the data, because we didn't have the system for people to use to generate that data. And so all of these are kind of ideas we have, and I'm happy to hear from all of you about other ideas that you have, maybe in this space or for some of these other projects. So my 3 bullets of scaffolding. I like being able to deploy this technology because, as you've seen, a lot of these technologies are for people with disabilities, where I think we can have actually a lot of impact in the real world right now. By putting things out in the real world, we can actually pursue data-driven approaches that may not have been so easy or practical without the crowd-powered system. And then if we have systems, components to some of these systems, like in that this big complicated diagram, you don't have to do all of this, which I think sometimes we do, right? So sometimes we feel like, before we can have that deployable conversational assistant, it's not like we can just do one part of this. We kind of have to bootstrap all of these things simultaneously to get to a working system. Whereas if you had a working crowd-powered version of the system, maybe you could just start introducing components just at one at a time to see how they might work without having to do everything at once. All right, so I think that is basically the end of my talk. So I thank all these people, but if you thought any of the things that I talked about today were interesting, I might encourage you to sign up for my course next semester called Crowd Programming, where we will talk about a whole slew of topics related to crowdsourcing and basically using the crowd as part of programs. And also, I wanted to advertise HComp 2014, which is a conference on human computation. We had our first conference this year, led by Eric Horvitz of Microsoft Research and Bjorn Hartman from Berkeley. And next year, David Parks, Harvard, and I will be taking over. And it's a community that's very cross-disciplinary. AI, machine learning, economists, all kinds of people come, including API people. And so I very much encourage you to submit. Who knows, it may be in Pittsburgh or Miami, pretty much the same. And probably sometime in November, submission deadline in roughly April. All right, thank you. Yeah?
Seems like there's a connection somehow with people who work on Wizard of Oz type characters, with robotics and things like that. Can you talk about any connection there?
Yeah, so one, I guess I didn't have the slide this time. A lot of times we call this deployable Wizard of Oz, right? I think a lot of times, at least the traditional way of looking at Wizard of Oz has been much more, let's get it to work maybe in a lab setting, let's get it to work for a study, and less about making it work, say, longitudinally so that you could actually deploy it as part of a system people would use in their everyday lives. I think it's basically the same thing. It's just now we have these sources of workers that you can call up on demand. So the wizards are in the cloud or something. Yeah?
How long did it take you to go from thinking about the problem to actually deploying one of these things? What's the timeline for any one of them?
Well, so the one I've had the most experience with is VizWiz, which is also kind of the simplest in a lot of ways, right? So I remember talking about it in 2009, doing a study with it in late 2009, and then we didn't deploy it widely for another year. And part of that was just, part of that was I was moving around, but part of that was also just getting a sense of how that would work and whether it would work. Because we weren't sure how many people would use it, for instance, and we wanted more experience with it. That's kind of that timeline. The other systems, surprisingly quick, especially once we have kind of this basic infrastructure available. So for us, it's very easy to, say, recruit a bunch of workers and send them to an interface and kind of deal with the feedback and the rewards, like paying them and things like that. So we have that basic structure. It's a lot harder, though. So for Scribe, we've had that for now a year or so, working in the lab and studies. But it's actually complicated enough that it's pretty hard to then push it out. And so we're still actively working to make that work reliably. We did caption part of the assets conference with Scribe, but it's very much we were hand-holding the technology. I think it varies, but I don't know if that answered your question. What's that? Yeah, I think so. I mean, I think with a lot of this, you want to kind of do like little studies and deployments and then build up to potentially a lot of people using it. Yeah.
It seems like you could almost tap sort of volunteers on the internet to really get common good. I think VizWiz is like almost kind of similar to that.
Yeah.
Are there any like applications in mind where you could really like make social good by tapping all these volunteers or just reading Reddit or Slack?
Yeah. So I think that's a great idea. I think one challenge is, it seems like, so with VizWiz, we have a lot of people asking questions, but they're still not coming in all the time. And so one thing you have to kind of worry about with, if you want to bootstrap a volunteer community, is that someone's going to show up and there's no work for them to do. It sounds kind of weird, right? Because you think, well, oh, good, they don't have to do work. But so trying to figure that out. I don't think that's insurmountable. We just haven't really done it. One thing we are running a study on now is kind of a play off the pushing VizWiz questions to Facebook, where instead of pushing them to your own Facebook network, we actually allow people to sign up for an app where the questions would appear on their wall. So it's separating the social networks. What's interesting, and the other thing we're kind of trying there is to look if people can kind of trade off their own social capital for volunteer tasks that they care about. So like you might care about this application for some reason, so you install the app, it would post on your wall, and then your friends would answer the questions, right? So kind of like volunteering your friends for things, micro-volunteering your friends for things that you care about, and seeing how that works. Yeah, there's a lot of questions. I think volunteer, there's a lot of things you could do. It would be great if there was, for instance, an alternative to Mechanical Turk that was only for volunteer tasks. I think there's a lot of stuff you could do. Yeah.
Yeah, I think it's really cool that you're able to do actually better than the professional stenographers. I mean, I guess this is kind of a vague question, but do you think there's any kind of like general principles behind like a lot of these different tasks? Is like how to take some sort of more complicated tasks and keep them to this person? I mean, obviously there's things like coding, right, but that doesn't really apply in these more complicated kind of tasks.
Yeah. Well, we thought about it. We're still trying to find maybe what that general model is. So far, yeah, I mean, we've been getting a lot of experience with these one-off systems, and there are some similarities, right? So I think, Legion had people collaborating in real time, and I think it has more similarities with Scribe than it does necessarily with VizWiz, because in both of those systems, people are working at the same time, and if nothing else, it's too slow to have humans do the combination. At least it seems too slow to have the humans do the combination. So we have the machine do the combination. I like that because it gets at these problems where neither the crowd nor the machine can do it completely by themselves well, right? So Scribe wouldn't work if we didn't have the computation to stitch the pieces back together. And so I think there's interesting spaces there where an individual maybe can't do it, a group can't do it, and the computer can't do it, but somehow figuring out how to merge them together, maybe they can. And that's one commonality, just that computers are very fast, but their sensory perception isn't as good. So maybe the crowd does the sensory perception, the computer does something to combine them, but it's not, there's not a fully baked idea there. Yeah, so we haven't done a lot with gaming. I mean, the closest is which I wouldn't always describe this as gamification. I want to give those points and things, like giving people feedback, like basically taking lessons from what makes games work. We've done that. We haven't really gone too far with the games. The challenge, of course, with games, and why many of us work on Mechanical Turk, at least to start, is that you have to convince people to play your game, right? Which there's great examples of people from here with ESP game and other things doing that. There's a lot of examples of games that just people don't play, and it's really difficult to design a game that you can be sure people will want to play, I think. Or it's easy to pay somebody 5 cents. So that's the real answer, right? Yeah.
Hey, question is briefly, quality control doesn't seem to be something that you have to worry about. Is there anything about sort of the task you're solving that makes it so that the answer you give are just good enough?
I think there's a few things, depending on the system, the way that works out. So with VizWiz, what we really do is we don't just get one answer, we get 3 answers, and we just rely on the user to make sense of it. As I said, it's very, very rare. It's actually, we've never seen someone be outright malicious. Have people been lazy or try to game the system? So like one guy we noticed a long time ago was just entering like black for every answer. I don't know if he had some script set up or what, but anyway, it was just always black. And maybe he noticed that there were sometimes color questions, and that's a color. And sometimes it went by. And so in those situations, it's not that big of a deal for the VizWiz users, because if they ask, like, what medicine is this is, and they get the answer back black, probably not a big deal. Clearly, there could be malicious users, right? But again, you have to be. Most of the situations for VizWiz anyway are pretty contrived, right? Like, is somebody really going to go? And maybe they would. Don't do this. But is somebody really going to go on VizWiz and say, happen to get the question about like medicine dosage, and then happen to put it just a little bit higher, right? So like if you said somebody like take 10 of these a day, they're not going to do it, right? If you say take 0 of these a day, they're not going to do it. But if you say like 2 instead of 3, maybe they'll do it. And so I think that kind of thing. But others, there is quality control built into some of these other systems that some of I touched, some of it I didn't. Legion I kind of touched because you are kind of promoted to having control based on your similarity to other crowd workers. We kind of assume that most crowd workers are doing something, or the majority of crowd workers are doing something reasonable, and so you are likely doing something reasonable. I didn't touch on it too much, but we don't necessarily tell you when you're in control, right? There's a little bit of feedback. So we've manipulated the feedback there a little bit so that if we don't tell you you are in control, and we don't give you too much indication about what exactly other people are doing, then you're more likely to kind of just do the better thing. Scribe, we've looked at redundancy, and actually the way we created that precision recall curve, the way we can have a curve, is basically manipulate how much redundancy we require before we accept the word. So more redundancy, the higher precision, slower recall. Yeah, so I don't know. I think we definitely look at it a little bit, but I think a big part of it is just if the tasks are designed well, people get good feedback, real-time feedback, especially if you can, then they don't manipulate it as much because they don't see the value. If they're not getting rewarded, then yeah.
To give more complicated tasks, so do you guys model workers? I mean, in the sense that is he an expert in this topic, or does he know this particular?
Wait, which one did you say?
So how do you model workers? I mean, for example, one of them can be an expert in a particular area, and he might answer those questions.
Right. I think there's a great research direction in finding experts within the crowd, especially for things like chorus, where you might want experts. We haven't really done too much of that, and I think part of it is I'm still not really. I don't have a good sense of what the prevalence of different kinds of expertise is on Mechanical Turk. I know other people have found that to be maybe more interesting on other sources of crowds like Odesk, for instance, where there are people with explicit expertise that you can find. Clearly, other prior work has done things with finding experts. I think Aardvark was a question answering system where both they found people that were kind of a few hops away from you in the social graph, and then also had some expertise in different areas. And so there's been people who have worked on that. We have not too much. Scribe, we have looked at modeling workers just to get a better sense of how much we can trust them to maybe reduce the redundancy requirements for certain workers versus others. I think there's a lot more to do there. It's very interesting. I mean, in general, the idea of expert crowdsourcing is, I think, very interesting. We had a system where we deployed it in University of Rochester Medical Center, where doctors were asking themselves, like, each other, like, micro questions. And surprisingly, they actually answered. Everyone has this assumption that, like, you can't get, doctors are very busy and you can't get them to do things. But if you watch a doctor, they do all the same things that all of us do to mess around, right? Like, they're in line and they're texting or checking whatever. And so it's just designing a good way to get at this little bit of expertise. Well, so we started this, we started this looking more at assistive robotics, believe it or not, even though we kind of went far afield from that, and which have many of the same problems as we're actually training for the particular environment. And so we thought, well, maybe the crowd can kind of stand in for the assistive robots' intelligence and so it learns where things are, what the layout is. Anyway, we got very far away from that. And now it's more, we haven't quite figured out how to do it well yet, but the idea would be that many things are not accessible to users with different disabilities on their desktop. And so we could just temporarily turn your desktop over to a crowd worker or crowd workers so that they get you past that inaccessible thing. So that's the idea anyway. Yeah, maybe last question so we don't. Yeah. Oh, yeah. Well, okay, so there's a number of different things I could say to that. So one is, what I thought you were going to get at is, since we did this, there's actually been, like Michael Bernstein and others have this retainer model now. So it's basically a twist on this, where instead of having them do old work, they just kind of hang out and then they're alerted when new work arrives. And so you don't have to necessarily pay them as much to come back. One benefit of having them do old work, though, is that they get kind of used to the task. But anyway, that's not the question. I think you. I don't know. I think the numbers of blind people with iPhones in the U.S. We're actually worldwide, which is a whole other problem since our truckers mostly don't speak. Well, they don't necessarily speak the same language. People ask me this question. But somewhere around 50 to 100,000 is what I've heard. Which is actually a small subset of the blind population, probably because iPhones are very expensive, the data plans are very expensive. They're also, even though they're actually a lot better than, I think anyway, than the screen readers for computers, how do you use an iPhone? It's still very complicated, right? So the majority of blind people are actually older, they've gone blind later, maybe not too comfortable with technology anyway. And the interface provided, all the non-visual interfaces actually are just tricky, right? Like, it's one way to see that is instead of being able to use recognition, right? You can look at the screen, see what's there. It's much more about recall. So you kind of have to use it well, to use it efficiently, you kind of have to recall the right keyboard shortcuts. And instead of getting something that's a lot of information at once, the structure and all this, everything's linear. So the speech that you get is linear, Braille is linear. And so there's a lot of reasons why people don't use the technology. So I think 5,000-6,000 people is actually a pretty decent size for percentage of the market, especially since it's free though, so right, so it's probably easier to get people installed. All right, well, thank you all.